Okay, go ahead.
Good morning, everyone. I am Halim Çağrı-Ateş, and I'm from Computer Science and Engineering Department. And today I'm going to talk about TextSL. It's a screen reader accessible interface for Second Life, the virtual world simulation on the internet. So, first I'll give a brief background about the virtual worlds and Second Life. Then I'll talk about TextSL and how does it work and what's the motivation behind it. And then the major challenges while developing TextSL, and then some extensions to overcome these challenges. So, a virtual world is an online simulation based on a real world, and it works on a computer-based system. It tries to mimic the real world and tries to create an environment on the internet. And Second Life is one of the most famous ones on the internet so far. It's not just a game, it's almost another life on the internet for some people. So also its name is the Second Life, so it makes sense. On Second Life you can almost do everything you do in the real world, like making money, spending money by doing shopping, taking education, and communicating with others, getting socialized and everything. It's available to everyone, and anyone can join just by downloading it, creating your avatar, and going into the world, virtual world. But it's not accessible to people who are visually impaired. So the main motivation behind TextSL is to make these virtual worlds available to people who are visually impaired, so they can be like other sighted people in this world. So it's a command-based web interface, and it allows visually impaired people to access Second Life. The user can give commands as text input, so it's like any other, like MS-DOS, you can give text comments and get some feedback. You can get feedback as text or audio, and users can read this text using some special screen readers or any other device they normally use with the computers. And this screen shows in the upper part, you can see the main Second Life screen, and there are two avatars there, and one of them, the one in black, tries to create a new object. And on the bottom part, you can see the TextSL screen. It's just a browser screen, and there are some comments and text which gives you some directions, and it shows available options to you and waits for your command. And then it turns your command into Second Life command and sends it to Second Life server, so the other user can see you as a normal user. So this is an example of the interface between the Second Life and the user. You can give commands like move here, describe people, what's around, describe objects, etc. And it gives you the feedback, what's around you and what can be done with them, etc. So when a user logs into Second Life using TextSL server, all the communication between the client and server goes through the TextSL server, and it converts the commands to normal Second Life commands and converts the feedback coming from Second Life server to text, so the user can see and understand what's going on. So TextSL already has some basic features in Second Life, like moving the avatars, talking with others, sitting, jumping, etc. But to be able to fully use this virtual world, user should be aware of the environment. He or she should know what's around, what can be done with them, and what are their properties. So this is the motivation between these extensions. And the user also should be able to manipulate the environment by creating or editing some of the objects around. So the first one extension is Seek and Tag. It's a game for labeling and classifying the objects in the virtual world. So most of the objects in the virtual worlds are not named correctly. Most of content creators leave it at the default, so an analysis showed that more than 30% of the objects are called object in Second Life. So it's very difficult for unsighted users to understand what's around them. So somehow we have to give a meaningful feedback to the user. But manually labeling them one by one is almost an impossible job. There are lots of objects, and as you try to label them, there are others added to the environment. So manually doing this job is not very logical. It's possible to achieve this goal by computer-based solutions, but it's very costly and may not be accurate enough. In this kind of labeling jobs, humans generally do a better job than computers. It's more efficient and accurate to use human power instead of computer power. So Seek and Tag turns this task into a game. And the object of the game is basically users try to find and label the specific objects in a given time frame. So they got points as they find that kind of objects. They try to find as many as they can. So when multiple users agree on a label or a description or something, it's accepted as accurate and added to the training set. And the study showed that it's more effective than just trying to manually labeling objects because it's faster and more efficient. And another extension is called Synterava. It's a feedback synthesizer for exploring virtual worlds. In dense environments where there are too much objects and other people around, it's very difficult to give feedback user just telling one by one what's around and describe them. It may be overwhelming for the user and it makes it difficult to communicate. So there should be a mechanism to filter out some of the objects around. Iteration can be a solution, but it makes the interaction very, very slow, and in these kind of real-time environments, it's not very a good solution. So we have to eliminate some of the results. So Synterava basically follows these steps. It first collects the names and description of the objects within the given range, then filters out objects with non-descriptive names like object, and then it filters further by looking at their name length, description lengths. For example, it can filter out some objects with very short descriptions or very long names based on the preference. It groups the objects so the user can see the feedback in less words and in a more meaningful way, like instead of saying there are 3 chairs there, 4 chairs there, and other ones at the back, it groups them together to give more meaningful feedback to the user. And it can reduce or increase the amount of detail on feedback by looking at the preference. So it can give you detail about the colors, the shapes of the objects, or if you feel overwhelmed and do not like to have that much detail, it can reduce the amount of detail, so you get less results. The last extension I want to talk about is called IQtext. It's for synthesizing descriptions for animated objects. There are some objects which are animated in the virtual world, and by just saying their names may not be very meaningful to user. They should be aware of the animation and movement in the objects. But just saying object moved from a position X to position Y may not be meaningful also, because the object could be part of another bigger object, or the movement can be a part of another movement like rotation or like other movements. So we somehow have to get meaningful descriptions for animations. But most of the objects consist of smaller parts in this virtual world. And we should observe these parts one by one to identify the movement in the bigger picture, to see what's going on the big scale. So IQtext can recognize change in position, rotation, scale, or color. It uses object's name and the primitives and the change in their properties to construct meaningful feedback. And these are the results showing change in position, rotation, color, and scale. The movement are analyzed, and these results are got. And we used crowdsourcing for verifying the definitions. So we asked users to rate the definitions, and it gave very good results. So telling that we are able to get meaningful definitions from that animations. As a future work, we are planning to design a taxonomy of objects, so IQtext will be able to choose appropriate words for animations, not just saying it's rotating, it's moving, or something. It can choose other verbs. User should be able to create and manipulate objects, so it's another future work. And improving library we use is waiting. So as a summary, Second Life gives users to an environment, a real life-like environment. And TextSol makes this environment available to users who are visually impaired. And it's open to be improved. And we are trying to improve it to be available to use, to be fully used by visually impaired people. And that's it. Thank you. Are there any questions?
I have to confess that I don't get Second Life.
Okay.
But that's sort of not the point. It would seem that what you have here is potentially far more, and I would think far more useful and important as a tool for training expert systems, neural networks, and other artificial intelligence systems where recognition of data and giving meaning to data has to be done. Is that where this is really going, or is that too far away? What are your thoughts on that?
It's possible to use it, but In fact, the Texas Second Life is losing its popularity among users. So the project is in an unstable position. So I'm not sure about the future works, but about machine learning and neural networks. We tried some, but as I'm not an expert in machine learning, I not have that much information. But it's possible to use it.